Dear students, in previous video, we have seen that why probability term has came in information retrieval and how Bayes theorem plays an important role in deciding relevance of the document. Now, as I told you, in this video, we are going to see what do you mean by binary independence model and non-binary independence model. Okay, and it is used for what? Probability ranking principle. We are using this independence model for what? Probability ranking. Probability ranking means what? To find out how much a particular document is relevant to the given query that I want to find out. Okay. Now here, what I will do is I am having a document X. Okay. And it is containing n terms. So I will represent that document as X1 to Xn. Now that particular term may be present in the document or it may be absent. Okay. Means it may be not part of the document. Absent means what? It is not part of the document. Now, where you will get this term? The term will be present in the query. Then if it is present, I will make that particular X as 1. Otherwise, it will be 0. So here I am considering the two values, either 1 or 0. That's why the term binary. Now the independence means what? Each term is occurring independently with other term. Okay. Now, different documents can be modeled as a same vector. Why? Because here vector is generated based on the fact that whether particular term is present in the document or not. So it may happen that two documents are giving you the same vector. Okay, remember that one. Now, query means what? It is a set of the terms. Okay. Now you have to represent your query also in the form of a vector. How you are representing here your document as a vector. In the same way, you should represent your query also as a vector. That only we have seen in the vector space model. Okay. Now for a given query and for each document, we are computing its probability of relevance. Means whether that document is relevant to the given query or not, that probability I want to find out. Okay. Now, instead of considering the whole document, I will think this for a particular term. Okay. Because in query, there are a limited number of the terms. So instead of involving the whole document, I will concentrate on the term. And I am trying to find out whether a particular term is relevant to the query or not. Okay. By using what? The incidence vector that is representing D. Okay. Now, how we are going to use it? For that purpose, as I told you, we need two formula. One is a odd, which is telling you that probability A divided by the probability of A bar. That's why the probability of R is equal to 1 divided by the probability of R is equal to 0. Now, for this probability, apply the Bayes formula. Okay, which is telling you that the probability of A by B is given by probability of B by A into probability of A divided by the probability of B. So same we are applying here on the right side. Okay. Now, here what is important is, what is the challenging part is, before finding a particular document is relevant or not, you should keep aside the non-relevant document. So finding non-relevancy is a challenging task. Okay. Now, Ri is representing me what? The relevancy. Okay. So how I will get it non-relevancy as 1 minus Ri divided by your relevancy, that is Ri. So by using your inverse document frequency, finally I will get log of n divided by the small n. Okay. That is a particular term in all set of the documents. Now, P of I, that is the probability of occurrence in relevant document. How I am going to estimate it? That relevance will help me to weight that particular document. Okay. So here generally using your IDF formula, we are giving the weight as a 0.5. Means it may be relevant or it may be not relevant. Okay. So the 50-50% chances I am considering here. Now, here, what we are doing is, I want to find out PI based on the relevance RI. Okay, and that may be 1 is or 0. Okay, now for that purpose, I'm applying Bayesian theorem. So here V is giving me set of all the documents that is answer to my query. Using what? A prior weight. As I told you, you should assign the weight to the document based on its relevance, and then only you will get a set of the documents. Okay. Now we have assumed P is equal to 0.5 and V is what? The set of the highest ranked document in the model. Okay. Now using this P and R, we are going to find out Vi divided by V by using our IDF formula, N minus Vi divided by the N minus V. Okay, means here what we are considering is how a particular term Xi is distributed in the document V, which are highestly ranked. And if it is not retrieved, means what? It is not relevant. Yeah, means its weight is very poor. Now, why binary independence model was designed? It is useful for less number of the documents. Means if your collection is containing less number of the document, then it is useful. And it is assuming that your document is of the same length. Now, these are not realistic issues. Okay. In modern full text search, the document length may vary. The frequency of the terms in the document also may vary. So based on that, uh, we will change the weighing formula. Okay. So in weighing formula, I'm considering the length of the document based on its frequency. Okay. So how I'm going to consider it? The term frequency also I'm going to consider and document length also I'm going to consider. So the document length is given by D and Ft is what? My term frequency. And here what the values are telling you. TFD means what? The term frequency. Then the average length will be given by L and L average. Okay. And K is what? That is a threshold for your term frequency. Means your term frequency is limited by the K. Okay. And how much your document length can increase, that is controlled by B. So B is threshold for your document length. Okay. So here you should remember that as I'm increasing the value of K. Now what K was telling me? That it is a threshold which is controlling the term frequency in a particular document. Now, if I'm taking its highest value, if that frequency is more, then of course it will increase the term frequency. And of course, as the term frequency is increased, the relevance will be increased. Okay. So highest weight will be assigned, highest score will be assigned to your document. And as you are assigning the low value to your threshold, the score will go on decreasing. Okay. And the next one is what? Based on the length of your document also, the relevance is decided. Okay. But it should not go beyond a limit. Now, for that purpose only, I'm considering a threshold as a B. Okay. So this was all in which I'm considering if the query is long, then how we are going to use your weighting terms. Okay. Now, here, what we are doing is the same thresholds we have to use. That is the K and B. And we have to consider the length of your document and average length of the document. Okay. Now, here, I'm not considering any length normalization for query. That you should remember. Means I'm not setting any limit on the length of the query. If the query is long, how I'm changing my formula. That only I'm telling. And here you should remember that the value of a key should be generally 1.2 and 2. and your B, that is the length of your document, can be on an average 0.75. Okay, so this is all about how we are using a binary independence model and non-binary independence model in information retrieval. Thank you.